So yesterday, what did we do? We did, all these steps are the same, so you don't have to copy them down, but take a look at the difference in what we did yesterday. The difference in what we did yesterday, oops, where are we going there? There we are, is A equals 1. What do I mean by that? I mean this A here. The coefficient of the x squared term is 1. And notice, it's 1x squared. 1x squared. They all work out that way. But that makes the process a little bit easier. Just like factoring. When it's 1 with factoring, it's easier. If it's not 1, it's a little bit harder. And the nice thing, this isn't that much harder. It's got sort of 2 extra steps is what I would say. Okay? So what do we notice about this one? It's got a 2 in front of it. And if you read through these steps, okay, and so they're online. The first thing, after we make sure it's in the right form, this one is. There'll be one later on that's not. We'll see that one when it comes. We're going to start the same way by thinking about just the x squared and the x term. The extra step is I have to divide the coefficient out. This seems a little bit weird because this is like common factoring. But whether it's common or not, it has to be divided out. So 2x squared divided by 2 gives me x squared. So in other words, what I'm saying is this term inside the brackets has to be 1x squared. Okay, so I divide whatever this is out. Even if it didn't divide into 20, I still would have to. In grade 10, it kind of always works pretty nicely. There'll be a couple of questions where it doesn't in the practice, but on the test they'll all work out nicely kind of thing. But for this process, whether it does or it doesn't, you would have to divide it out. Okay, so what is 20x divided by 2? So plus 10x. So now I keep doing the same thing as yesterday. What's my number that turns this into a perfect square trinomial? Liam.
I just have a question.
Go for it.
Did you use 2x as the common factor?
Very good question, because 2x is the common factor. No, you can't. That will ruin this process. Yeah.
25?
It's 25, yes. Liam, I'm going to come back to that question a little bit after too and talk about it again, okay? And I add it and subtract it. And somebody asked this morning, well, can't we just put the 25 outside the brackets? Because you could do that yesterday, right? How many people, you don't have to actually answer this question, but how many people cheated and skipped this step with the negative 25 in the brackets? You just wrote it outside the brackets yesterday. Cheaters! I call cheaters. And you can't do that today. Why? Because what do these brackets mean? It means 2 times all of this. It means outside the bracket, it's multiplied by 2, but inside the bracket, the 2's over here. So what does that mean? It means this negative 25 outside the brackets is actually negative 50. Because it's 2 times everything in the bracket. If I want to pull it out of the bracket, I have to multiply it by the 2. Okay, so this is a little bit weird, so I'm going to say a couple things about it. So if you were cheating yesterday, just be careful if you develop that bad habit, because today it got more complicated. That's why I said yesterday, try to avoid doing that. This is what's really cool about grade 10 math. This doesn't happen in grade 9. It doesn't happen in elementary school. This is where we really start to get into like real math. Like at the end of this year, it's really cool because you're doing real math in grade 10 academic by the end of this semester. Like really good quality stuff. Like factoring, that's huge. But what's different about this is there's these 2 things. Liam pointed this one thing out. But isn't 2x the common factor? Right, it is. But see, there's no rules in mathematics that, like, I always have to common factor as fully as possible. That was the rule in learning to factor, but it's not a rule in mathematics. Why don't I want to do that? Because that's not going to put this in the right form that I want it in. I'm trying to put this in vertex form. In grade 9, when you see a question like this, 2 times that whole bracket, oh, I know how to do that. You distribute, so I distribute everything. But we don't want to do that in grade 10. We only want to get the negative 25 out. But that's weird. Usually if we multiply by 2, we multiply everything by 2. But in this case, you're only multiplying the negative 25. That's because that's what's going to work for us. That's really what math is about. There's no rule that every time I see this, I do this. It's almost like a game of chess. You have to be thinking a couple steps ahead. Right? If I do that, it's not going to work, so I want to do something else. So watch. Now we can finish this one. Now it's the same as yesterday. X squared minus, why is that minus? X squared plus 10x plus 25. How do I rewrite that? X plus 5 all squared. Make sure you're writing that the correct way. Minus 58. See, what is this? It's vertex form. What's the vertex? Negative 5, negative 58. It opens up. It has a vertical stretch by a factor of 2, so I can figure out the growth pattern. I know where the vertex is. With the growth pattern, I can graph this really well. I know a lot about this. If I had factored out 2x, I wouldn't have got this. See what I mean? But it would be hard to come up with this on your own. I mean, somebody did. But it would have been hard to kind of like, because usually when you factor everything, and we didn't do that. And why would you come up with 25 and add it and subtract it? Like, that's not a normal thing that we've done so far in mathematics. And then all of a sudden, we're doing a few different kinds of things. But you can see how this is getting into like a new kind of flavor of math. And if anybody's wondering, so on a different note, if anybody's still confused about that, people say things like, where did the 10 go? Or where did the 25 go? That's when I know, like, you haven't made that connection yet about the factoring, right? So watch carefully. If I come over here and I go, well, where's a good spot to do it? X plus 5 all squared is x plus 5 times x plus 5, which is x squared plus 5x plus 5x plus 25, which is x squared plus 10x plus 25. This is why we like to be able to factor. So I can take something like this and write it in a different way, in this case like that, so that it's convenient and I end up with what I want. That's the power of factoring. But that's the connection. That's how I go from this step to that step. Okay, let's try another one. What do you notice about this question? Jaden? Negative. So you don't have to write that first step where you put the first two things in brackets. It's just a nice way to introduce, like, I'm only looking at these two. I'm not worried about the negative 11 right now. It's by itself. So you can start by doing that. So I end up with x squared. It's got to be x squared. It can't be 2x squared. It can't be a half x squared. It can't be negative x squared. And what should the 12x turn into? Riley? Right. 2 ways you can think about this. You could think 12 divided by negative 1 gives you negative 12x. Or some people like to think of it backwards. Negative 1 times what will give me positive 12? Well, this has to be negative 12. So when I multiply it by negative 1, I get back the positive 12. Right? So you can kind of look at it both ways. Good. Okay. Now I just keep going like yesterday. What's my number? Liam. Close? Yeah, 36. Half of 12 is 6. Square it, 36. What do I do with that? Add it. Subtract it. Negative 36 times negative 1. Don't forget to multiply by this thing over here. Is positive 36. Everybody see that, or are you too busy writing or doing something else? It's negative 36 inside the brackets. It's positive 36 outside the brackets. And that's because of the negative. Okay. And then, don't forget that negative. X minus 6 all squared plus 25. Opens downwards, so this has a maximum. What's the maximum? It's 25 because that's the y value. And it occurs when x is positive 6. That's a shift to the right 6 spaces. It's a vertical shift up 25. It's a really good habit to kind of write out the vertex every single time. And opens down. Think about that at least, even if you don't write it out. Okay, get this one started. See if you can do the first step or a couple steps on your own. Okay, so hopefully everybody knows that you got to take the 3. But here's a common mistake. Even after you've done this a few times, once in a while we forget. Divide the 60 by 3. So check your work and make sure you have 20x. Now you're looking for your number. How do you find that? Divided by 2 squared. So 20 divided by 2 is 10. 10 squared is 100. Plus 100 minus 100 plus 2. 3 times negative 100, when I pull it outside, is negative 300. And there's the final answer. Listen carefully. Those are the 3 steps you should write every single time. Some people start to get cocky and they start to think, hey, I'm pretty good at this. I don't think I need to write that step. And even if you are good, I have just noticed people make mistakes because you start trying to do too much in your head, your brain overflows and forgets something. So I'm telling you, 3 steps is the magic number to success with completing the square. If it didn't have a common factor of 3, you might be able to do it like in 2 steps. But don't push it. If you wrote any of these steps differently and made a mistake, there's your proof. I'm just telling you. This is my experience. Those are the 3 magic steps to success for completing the square. Okay, let's try another one. Yes. Okay, so somebody tell me what my first step is? You got the question written down? What's my first step? Yep. Okay, so I write 3 out here, right? Yeah, and what do I get? Very good. So that's your first step. You can stop this step here if you want, or you can find your number that you add and subtract now, right? Like you could close the bracket and do +2, or you could do more of the algorithm. What's different about this question is what's 9 divided by 2? It's like 9 halves, like 9 over 2, the fraction, or 4.5. This is the first time we've seen where when you take half the middle term, you don't get a whole number. You probably won't see too many of these, but they do come up, and in this case, it's pretty straightforward. 4.5, use your calculator. What's 4.5 squared? So just 20 plus 20.25 minus 20.25 plus 2. Y equals 3x squared plus 9x plus 20.25. Bracket 3 times negative 20.25 is negative 60.75. And then write it in vertex form. And it's x plus 4.5, half of 9, squared minus, in this case, 58.75. That's not too hard. And we're always dividing by 2, so that the worst you're going to get if you start with a whole number is something 0.5. And then when you square it, that'll be something 0.25. So every time it's going to be like relatively easy kinds of decimals. Put your pencil down and watch for a second. One way to check your work as you're doing this is every time when you get to this second last step, that is a perfect square trinomial, and it has to be. It's a little bit harder to see this time, but it's always a simple trinomial. How do you check it? You could do the same thing. Take half of 9 and square it. You should get that. And the square root of that should give you 4.5, and half of 9 should give you 4.5. Little checks to make sure that what you have done is correct. Every time, that has to be a perfect square trinomial. That's why it's kind of important to understand that relationship here. We are designing it that way. You can't get to that last step. Well, what if it's not a perfect square trinomial? No, it has to be. You made it that way. You picked the number 100 to make sure it worked out. Okay, try this one. This one looks different. It looks like maybe there's a trick to it because there's no constant, but it actually ends up being easier. There's just sort of one fewer step at the end. So give it a try. All right, let's see. How are you doing so far? So when I do this, y equals negative 2 bracket x squared. What's 8x divided by negative 2? Negative 4x. And even though you kind of know that, it's still easy to miss one or the other or both or something. Like people forget. It's just one of those common mistakes, so really watch for that. Half of 4 is 2 squared is 4 again, so plus 4 minus 4. No number on the outside. X squared minus 4x plus 4. And then negative 2 times negative 4 outside the bracket is plus 8. So again, sometimes people forget either the negative or the multiplying by 2 or something like that. Okay, and I'm going to give you a minute to see if you can, if you didn't get all that, to catch up and see if you can write it properly. Y equals negative 2 times x minus 2 all squared plus 8. The vertex is positive 2, positive 8. It opens down. If I'm graphing this, I'm going to go over 2, up 8, and then it opens down and has a stretch. So over 1, down 2, and then over 2, down 8. So look at that. I'm on. That should be going through the origin there. But anyway, if you had a grid, you could graph that nicely. That's how fast you want to be able to, like, that's not an accurate graph, but you want to know, be comfortable enough with parabolas and this sort of thing, quadratics, that you could kind of sketch it roughly like that quickly. Okay, next question. Last one. What's the different about this one? What's a little bit different? Tony? Yeah, it's not in that proper form. That's right. We have to kind of simplify it first. So how would we do that? We're just going to take x and subtract by x on both sides. Y equals 0.1 x squared minus x plus 3. Notice where I put the negative x? Remember when we first started doing this stuff a couple weeks ago, and you probably, some of you or a lot of you, had this question in your head. Do we have to write it in that order? Remember thinking about that, especially when we were expanding? Do you have to write it x squared, then x, then constant? Just imagine now, with everything we've done with factoring and completing square, imagine if you didn't. Imagine trying to do these things with the terms out of order or in different orders every time. It'd just be a lot harder on your brain. Your brain relies on those patterns, those habits. So I think you can probably look back and see now why we have a standard of how we write these things. X squared, then x, then 3. Okay, first step. Divide out the 0.1, but I want to just think about one more thing in this question. Something kind of weird happens here. I've got negative 1x divided by 0.1. What does that give me? Yeah, so negative 10x. And that's weird. How did it get bigger? Yeah, it gets larger. Like, think of it. Some people, this baffles them, and it never really clicks. What is division? How many times does 2 go into 8? It goes in 4 times. How many times does 0.1 go into 1? It goes in 10 times. What's 4 divided by 0.5? No. 4 divided by 0.5. 8. How many times does 0.5 go into 4? It goes into 8 times. A lot of people would think it's 2. 4 divided by 0.5, because a half of 4, but you're dividing by half, not multiplying by half. Anyway, careful of that. Okay, so half of 10 squared is 25. Zero 0.1 x squared minus 10x plus 25. And what's negative 25 times 0.1? Very good. Negative 2.5 plus 3 x squared. Oh, no, not x squared, sorry. X minus 5 all squared plus 0.5. Vertex form.